Hello, 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 2.7 absolute values and their graphs. So right here, we have absolute value. Now we talked about absolute value in chapter 1. Now we're going to actually get into what the graph of an absolute value line would be. So if I were to make a table and I'm picking any number, so I'm going to put 0 in the middle, I'm going to evaluate this function 1, 2, 3, -1, -2, -3. So if I plug this into my equation, that would give me 3. If I plug 2 into this equation, that will give me 2. If I plug 1 in, if I plug 0 in. Now if I plug -1 into this equation, absolute value of a -1 is +1. Absolute value of -2 is +2. Absolute value of -3 is +3. So if I'm going to plot all these points, I go over 3, up 3. That's that first point. Over 2, x is 2, y is 2. X is 1, y is 1, 0, 0. At -1, it's up 1. At -2, it's up 2. And at -3, it's up 3. So this is what my line, my graph looks like. It's two straight lines and it forms a V. So when I'm looking at this equation, this parent function, the V has a vertex, basically where it starts to form the V. My vertex here is at 0, 0. When you have your vertex, you should be seeing symmetry, so seeing the same things on each side of your Y value. So my axis of symmetry will be the line that never, where if you create a line, it's the same on both sides. If it were to have a reflection, it would be at x equals 0. Once you have your vertex, it's always going to be that x value. When I look at this, my graph, the high or the lowest point, so this is going to be a minimum. My lowest point it ever hits will be at 0, 0. When I'm talking about up and down, I'm talking about my y value. I'm talking about my y value. Again, that's based on my vertex. Transformation, there is no transformation in words. We'll get into that with other problems. But because this is the parent function. So this is the function we base everything off of. Now when I do my domain, when I'm looking at my x values go on forever over here because of this line. That means it's going on forever. So it's going to be -infinity. Domain is x. When I look at on the right-hand side, so it's the left to right, goes on forever. So that's going to be +infinity. So again, you could either have this or you can write all real numbers because x can be any number that you want. When I look at my range here is y. So when I'm looking at my y, how far down do I go? So this is the smallest point that y gets. It would be 0. And if I go up, well, these arrows are pointing up forever. So it goes on to infinity. So you could either have it written like this, or if you know your vertex, you can simply put the point that the vertex is at, and you have to think, is the graph above it or is the graph below it? The graph is above it, so that'd be greater than or equal to. So now we're going to actually get into the transformations of a graph. So when I'm looking at this, we have different transformations. First, if this positive, negative, if this number out here is negative, it will flip. If we have a number being multiplied on the outside of the absolute value, you should be writing this down. Outside of the absolute value, this will either stretch or compress. So again, this A value, if this number is larger than 1, it'll stretch it out, it'll get skinnier. If it's less than 1, it will compress. Not talking about if it's negative, the negative will flip it. If I have the H on the inside, so if there's a number on the inside adding or subtracting right here, if it's going to be a positive, it's actually going to be moving to the left. This is opposite. If it's going to be negative, so right now it shows negative, it will move to the right. So that's on the inside of my absolute value. Here, if I'm adding or subtracting on the outside, if it's positive, it's going to move up. If it's negative, it's going to move down. So now knowing this, I'm going to look at this right here to help me figure out what's happening to this graph. Transformation words. So I have this number out here. That's this number. So when I look at that, that's greater than 1. So it's going to stretch by 2. So that's the number. This number looks like this number right here with my H, and it's a negative. So since it's negative, it's going to move to the right. So in this case, it's going to move to the right one. And this 3 is kind of like this K back here. So then it's positive, so it's going to move up 3. Right now, I want you to pause the video and try to do the rest of these by yourself. So this right over here will flip or reflect over the x-axis. This is on the outside, so it's going to move down 1. Here, this is less than 1, so it's going to compress 1/3. It's on the inside, so this is where it's opposite, so this is going to move to the left 5. Here, I rewrote this problem, so you can always rewrite the problem. Now that I have it rewritten, this negative will flip it. Now this 3/2, even though it's a fraction, will still be a stretch because this is a 2, because it's larger than 1. 3/2 is larger than 1, so that would be a stretch of 3/2. And this is on the outside, so that would be up 5. So now we're going to graph those. So now if I were to make a table, you can make a table if you want, and I will also show you in class how to get the table on your graphing calculator. Your vertex is the transformation if you move left or right or up and down. So in this case, this is the same one that we did before. This is going to move it to the right 1 and up 3. Right 1, up 3. That's going to move our vertex because really we're just moving that parent function. My axis of symmetry, again, that's that x value. So in this case, x is equal to 1. That's where it's going to be reflecting on both sides. This is not flipped. So since it is not flipped, that means this is going to be a minimum at y is equal to 3. That's the smallest you're going to go. Now we're going to actually draw the graph. When I draw the graph, I'll show you how to get these points in your calculator in class. But this is where I'm going to be plotting these numbers on this graph. What if I didn't have my graphing calculator? You could plot that point, and this right here is like your slope. This would only be true. But the thing is that you have to remember you can go up 2 over 1. But on the other side, you have to do the opposite because remember you need a positive and the negative accounted for. So my domain is moving to the right and all to the left. That arrow means it's all real numbers. My range, this is the smallest that my y will get. So that's at 3, and my graph is above it. So y is greater than or equal to. I want you to try to do B by yourself. So my point here, I did not move left or right, but I moved down 1, so that's my vertex. Remember, your axis symmetry is the same as your x value. This gets us a maximum because of this flip. So if I were to plot that point, my slope here is going down 1 to the right 1. So whatever you do to one side from your vertex, you have to do to the other side. You need to be having a V. One thing that I tell people is to, whenever you see this absolute value, is to draw a V so you know your answer should be a V. We're going to do these two in class. We're going to get into writing the equation. Bam! First thing I'm looking for is my vertex. So this number right here is over 2, up 4. And then from this point, I'm only going to focus on the right. I'm going to look for a nice number. So here's a nice point also. Remember, it has to hit the corners. Here I'd have a rise of 2 and a run of 3. Rise of 2, run of 3. That's my A value. That's my A value. Since it's pointing up, it's not flipped. So when I'm writing this out, y is going to be equal to, it's not flipped, so it's not negative, my A. Your x stays the same. You subtract. So this is positive, so I'm going to be subtracting 2. Remember, that h value is always opposite, and I moved up 4. If I were to look at this one, here, my vertex is to the left 1 and down 2. Now when I look at my slope from your vertex to the first point on the right, I'm going down 1, 2, 3, 4, 5, and to the right 1. Down 5 to the right 1. So my A value is negative 5. So when I write this, since it's negative, it already has the flip with it. And then I have x. This is opposite, so it's going to be plus 1. And then I'm going down 2, so it's going to be minus 2. I want you to try to do this last one by yourself. So you should get your vertex at 0. Oopsies. Negative 1. That should be a negative 1. And that my A value went up 3 to the right 1, so it's positive. You could put a plus 0 here if you wanted to, but you don't have to have that there. And this should actually said negative 1 because it went down 1. And there you have it. We will do these two in class tomorrow, and we will definitely do it on a graphing calculator too. Have a grand day.